Hello, everyone. Today we are going to study chapter 7, techniques of integration. So first, let's talk about 7.1 integration by parts. This is a very important technique in math. So let's first review a formula we studied in differential theorem. So that's called product rule, right? So we assume we have a function f(x), g(x) are both differentiable. And then the product rule says the gx times fx is derivative dx is fx g prime x plus gx times f prime x. Okay. So for this formula, let's take the indefinite integral. So we take the indefinite integral on both sides. We will get the integral of fx dx, the derivative is right, is equal to fx g prime x plus gx f prime x dx, right? Okay, for the right hand side, right, we can write this is fx g prime x dx plus integral g x f prime x dx, right? So what's the left hand term? By the fundamental theorem of calculus part 2 or part 1. So anyway, just by the definition of antiderivative. So we have this is equal to fx gx, right? So we obtained a formula which is fx gx equals to, okay, fx g prime dx plus gx f prime dx. This is not what we want now. We can move this term. No, we can move the second term from the right hand side to the left hand side. So move the second term to the left. So, and then we get fx gx is a minus gx f prime x dx is fx gx prime. So we can rewrite this formula in the following form. We just rewrite it as the following form. That's not math, we just rewrite it. This is fx g prime x dx is fx gx minus f or gx f prime x dx. So for this formula, we give it a name. So this is called formula for integration by parts. Okay. So let's, do some substitution. Okay. If, okay, furthermore, we said, okay, u is fx. Okay, v is gx. And then we have du is f prime x dx. dv is g prime x dx. And then let's plug in dv into this formula. Okay, look at the arrow, look at the formula. So we obtained, okay, f is u dv, we know dv is g prime dx, right? Equals to u v minus integral g is v, right? F prime x dx is du. So this is another form for the integration, another formula for integration by parts. Okay, if you look at this formula, it's kind of, this formula has more structure. It's easier to recognize the structure. So it's kind of, the integration by parts states, okay, the integration of du dv is equals to u times v subtracted and then minus v and u, right? It's kind of, you change the order of uv and other minus, right? So you may ask me, why do we do this? In general, when you are doing a problem, this part, you may say, okay, why does it? Though in general, I write a remark, when you are doing a problem, it is possible that the left term is complicated. Means that it's hard to find an answer. You use the equation by parts, you get a term uv and minus v du. Why do we do this? Because this is complicated. After we do this, we hope this term, for this term, it's easy for us to find the derivative, the antiderivative. Okay. This is one, the second one, the goal, use the integration by parts to get a easy function or simple function for which it's easy to find the antiderivative. It's kind of like this. You use the integration by parts. You still have the integral, right? But the goal is that, okay, we make this term very easy to find an antiderivative. That's our goal. So it's kind of, for this term, it should be easy to find the antiderivative. Okay. So this is about the integration by parts. So in the following, I will give you some examples. So let's look at example 1. So this example is x sine x, right? For this example, we don't know how to get the antiderivative directly. Probably you can get it directly, but I cannot. So we will use integration by parts to find the antiderivative. So let's first, write the formula here. So this formula is kind of like this. So f g prime dx equals to f g minus, g f prime dx, or you write u dv equals to u v minus v du, right? So how do we do this problem? So if you want to use the integration by parts, you have to find what's u, what's g prime, right? So let's see it. Okay, fx is x, g prime x is sine x, right? And then if you look at this formula here, right, you have to find what's f, we already know, and g prime. So we compute f prime x is 1, gx is negative cosine x. So you may say, okay, because we know if gx equals to cosine x is the antiderivative, you add any constant, it's still the antiderivative of sine x, right? In general, you don't have to write a plus a c here. Okay, if you add a c here, that's okay. I hope you will not add a c here, because add a c here, it will make your computation hard. Okay, so and then the formula says, okay, this is f g prime dx is x sine x dx, right? By the of integration by parts, this is f x gx minus gx f prime x dx. So we plug in x is x, gx is negative cosine x, and minus gx is negative cosine x. Wait, just add a bracket. F prime is 1 dx. So we get this is x cosine x plus negative, we get a positive cosine x dx. So we have to memorize the formula for cosine x. So this is x cosine x plus sine x plus c. Don't forget the constant c. So by the computation, so we get the integral or the antiderivative of x sine x dx is cosine x plus sine x plus c. I'll emphasize it. Don't forget the constant c. If in the test you forget the c, you may lose 1 or 2 for your lose. Okay, so for this kind of problem, how do we do it? So in general, when you are doing this problem, I hope you write it in this format. So let's write it in this format. Okay. Okay. So let's use another way to do the example 1 again. So like for the first method, we use F and G, right? We may use the second one. It depends which one you like more. So how do we do this? So if we are doing using the second formula, you have to find what's U, right? And what's dV, right? So what's dV, right? And then you have to compute what's du, right? Right, du is obtained from U, and what's V, right? You can compute V because you know dV, right? And then let's use this method to do this problem. Okay, so let's erase this scar. So for this problem, okay, if you look at this, U is kind of F, right? So we have U is X, dV is sine X dx, right? And du is dx. V is negative cosine X. And then we have X sine X dx is X sine X dx. So by our setting, this U dV, right? And then by integration by parts, this is U V minus V du, right? U is X, V is cosine X, minus V is negative cosine X, and du is dx. We have, this is X cosine X plus cosine X dx. This is X cosine X plus sine X plus c. So it's kind of, we use two methods to solve this problem, but they are equivalent to each other, right? Because for this part, we just rewrite G prime dx as dv, and U is F, right? So this is our first example. So if you look at this problem, you may feel you know, when you are doing a problem, you have to figure out what's U or what's F, what's G prime, or you have to figure out what's U, what's DV, right? If you figure out, you know, what's F, G prime, it is equivalent to you figure out what's U and what's DV. After you figure out what's U or what's DV, and you can find the du, right? It's very easy to find out the derivative or differential. Also, you have to find a way. If you want to find a way, you have to, know the antiderivative, right? That's if you are trying to find what's dv, should be easy for this term to find the antiderivative, right? Otherwise, you cannot find it, right? So when you are doing your problem, if you want to use UDV, I hope you can write in this box form. Okay, that's just my suggestion. You know, it may help you to write it clearly. Okay, so this is our first example. So let's look at our example 2. So this example is ln x dx. So like I said before, so if we use u dv, this is equal to uv minus v du, you find, so what's u, right? What's the, right? And then you compute the du, and then you compute v, right? You find uv dv, and then you compute du and compute v. So for this problem, we said u is ln x, dv is dx, and then we have du is 1 over x. We have v is x. Like what I said before, you don't have to add c. I hope you know it's better not add a c here. Okay, so it's kind of we always assume c is 0. So and then we have ln x dx. This is u dv by the the formula of integration by parts. This is uv minus v du. So uv is x ln x minus v. What's v? V is x, right? What's du? Du is 1 over x dx. So and then this is x ln x. For the second term, this is dx, and then this is x ln x constant. The antiderivative is, sorry, it's minus, not plus, minus x. Don't forget the c. Like I said, forget the c, you'll lose some credit, score. So we obtain ln x dx. Its antiderivative is x times ln x minus x plus c. Okay, don't try to memorize the antiderivative for ln x. It's unnecessary, right? Even you can remember it. So what? You just try to study the method, integration by parts. If I give you a problem like this, you have to repeat this process. You cannot just say, okay, I can memorize it. Okay, so this is our first, the second example. This is second. Oh, it's kind of, like what I said, after using integration by parts, for this part, it should be easy to find the antiderivative. It's kind of, this is our goal. Okay, that's our second. So let's look at our third example. So this example is t squared et dt. So we still want to use the integration by parts. Okay, like what I said, you have to first find out what's u, right? What's dv, and then compute du and get v for this one. So let's set u is t squared, dv is et dt. So we have du is 2t dt, v is et, because you know the antiderivative of et is et, right? You don't have to say. And then we have t squared dt, et dt is, by the setting, is u v. You don't have to write this if you can jump this step. You know, I just write it to help to get familiar with the formula by parts. So this is the uv minus v du. So this is uv is kind of, you know, t squared et. Okay, let's erase the extra star. So this is, what's v? V is et. What's du? Du is 2t dt. So let's just rewrite it. So this is 2, right? T et dt. So you can feel, right? For the second term, we still don't know the antiderivative. But if you observe t squared times the et, if you observe the integrand, right? And this integrand, you can see the power for the t is decreased by 1, right? So now let's look at the second term. So let's look at the second term e and et dt. So we still don't know the antiderivative, right? We still don't know the antiderivative directly, right? So how do you do it? Let's reuse formula of integration by parts again. So we said u is t, v dv is et dt. So we get du is dt, v is et. So we get t et dt is u v, right? This is uv minus v du. So u is t, v is et, minus v is et, du is dt, right? So t times et minus the antiderivative of et is et plus c, right? Now we combine all the computation together. We get, okay, t squared et dt is t squared t minus 2 times of this, minus 2. The antiderivative of t et we computed here. This is t et minus et plus c. So let's simplify. This is t squared et minus 2t et plus 2 et minus 2c. Okay. It's complicated, right? You know, if you are getting familiar with the formula of integration by part, it's not that hard. You need some practice, you know, and finally you will know how to compute it, you know, this problem. So let's look at example 4. Okay. This is ex sine x dx. Anyway, I don't know how to get the antiderivative directly. So we should use integration by parts. So like you first, you may say, okay, what's dv? For this, we can see u is ex, dv is sine x dx. It's kind of, you know, we put this term together. We set it as dv. The first term is ex, and then du is ex dx. V is negative. Don't forget the negative cosine x. And then let's use integration by parts. This sine x dx is u dv. This is uv minus v dx. This is cosine x ex minus v is cosine x d. Sorry, this is du. This is du. Du is ex dx. So what I want to say here, when you are doing a problem in the homework or in the test, if you are already very familiar with the formula of integration by part, you don't have to write this part. You don't have to write this part. I write it just because I want to, you know, remind you or help you to memorize it. So we get ex sine x dx is cosine x ex plus cosine x ex. Okay, so if you look at this, we still get a, you know, a trigonometric function times the exponential function, right? We still don't know how to compute it, right? We still don't know how to compute the antiderivative. What do you do now? You know, this kind of example are very special. You know, after if you meet this kind of problem at the first time, it's very normal. You cannot figure out, you know. But after I teach you this example, you know, if we have a similar problem like this in the future, you just follow this method, you know, because, you know, they have the similar phenomena. So what do we do next? So we continue to use the integration by parts. How? So we said, okay, what to do? We said u still ex, and dv is cosine x. You may ask me, how do you know this? You know, nobody knows at the beginning. You need to study and finally figure out it. Okay, and then we have du is, okay, du is ex dx, v is sine x. So, and then we have sine x, ex dx. So we just write as ex cos x dx. I will not write uv here. So this is ex sine x minus, okay, minus sine x ex. If you you cannot write this so fast, you just write the box here, okay. And then magic happens. So we connect this term, we connect them together, so we will get ex sine x dx equals to cosine x ex plus ex sine x minus ex sine x dx. So you can say this term, they are the same if we just change the sign, right? So it means that we move this term from the right hand side to the left hand side. So we will get 2 times ex sine x dx is ex cosine x plus ex sine x. So we obtained ex sine x dx is half ex sine x minus cosine x. Okay, here, don't forget the constancy. Okay. That's this problem. You can say this problem you use. Okay, I write a remark. We use integration by parts 2 times, right? Finally, we get, in the integration by in the integral part, we get the same integral as the original one, and then we move it together. So in general, if a question like this, so we have a trigonometric function times exponential function and dx. So we always assume u is the exponential function, and then dv is trigonometric function dx, and then you play the integral by parts 2 times. You will get, if we study, we write this as e, this is e, right? So we will have e dx, you will get a function, some function minus t e dx. Like this example, it's kind of, this is kind of, law, right? It's just for the method. It's not hard. Okay, you will get some practice, in your homework. Anyway, no worries about this. Just follow this process. It's quite easy. Okay. So before we continue to give you an example, so let's first, study a new material. So let's recall. This is f x g prime x dx, right? By the integration by parts, we have this is fx gx minus gx f prime x dx, right? This is the version of or indefinite integral version, right? If we evaluate this indefinite integral by the fundamental theory of calculus, we will have a new formula. Or you can say this is a definite integral version of integration by parts. So the formula is we evaluate a, b, f, x, g, x, dx is fx, gx, evaluate a, b minus the definite integral from a to b, gx, f prime dx. Okay, so this is the kind of definitely the integral version of integration by parts. So let's look at one more example. This is example 5. Compute the definite integral from 1 to 0. 0 to 1. So tangent negative 1, the inverse function of tangent x dx. The same, we have defined what's u, what's dv. For this, we assume u is negative 1 dx, dv is dx, and then du by the formula. This is 1 plus x squared dx, v is x, right? So we have tangent negative x dx from 0 to 1. So this is uv x tangent negative x from 0 to 1 minus the integral from 0 to 1, right? So this is, okay, vx du is 1 over this, right? So we have, this is 1 times tangent negative 1 minus 0 times tangent negative 1, 0 minus x plus 1 plus x squared dx from 0 to 1, right? So we get, what's this? Tangent negative 1 is pi over 4. So we get this is pi over 4 minus the integral from 0 to 1 x dx, right? Now If when you compute this integral, so means that we have to compute this, right? How do we compute this, right? I think you studied this in Calc 1. So now let's compute. For a moment. What happened to my computer? Oh.